Welcome everyone to this new video tutorial. We're going to see today face swapping. We have the faces of two actors, one Bradley Cooper and Jim Carrey, and we want to swap their faces. So we first select the face of the first actor this way, and by the way, this is just an explanation of what we're going to do with Opencv and Python. So we take his face this way, The face swapping will be done in 3 steps. First, we need to find the facial landmark points that we have also seen in some previous video. So this one, we find the facial landmark points, and then from these facial landmark points we can find all the area around. So we don't need the center one, we just need to know the area around to recognize the boundaries of the face. Once we get facial landmarks, second we get the area around, finally we can swap the faces. You will see that we will get only really rough face swapping, and later on we will have many problems to solve. First one that it's clear to us is the difference of the color. You can see that it looks like a collage, it doesn't look like a real face swapping. So this is one problem that we need to solve. Another problem is the size. If the face, as in this case the face of the first actor, is smaller than the face of the second actor, and we can see there is still some space here around. And finally the rotation of the face. So if we do the application in real time, we need to be able to rotate the face. Let's now start with the first step, detecting the face landmark and find the boundaries of the face. I will go really quick with the face landmark detection, as I've explained it already in another video. So if you don't know how it works, I suggest you to watch the other video about face landmark detection. Let's import CV2. We import numpy as np. We import the lib library. We load the first image, emg is equal to c2.im read Bradley Cooper.jpg, and you can download this image from the link in the description. And now let's go on and display the image. c2.im show image 1 and emg. Wait key event cv2.wait key 0, and final cv2.destroy all windows. Let's run it really quickly. I always use this practice to run the script so that I check if there is any error each time, and it's correct. So let's move on. Now let's detect the face. So we load the face detector from the lib library. The detector is equals to the lib.get frontal face detector, and once we have the detector we can find the faces. So faces is equals to detector, and we want to detect the faces on the gray frame of this image. So first we need to convert the image in gray frame format. emg gray is equals to c2.cvt color of the emg, and then c2.color_bgr format to gray format. Once we have the emg in gray format, on that image we can find the faces. The faces will give us an array of more faces. So we don't want to work with all the faces together, but we loop through each face. So for face in faces, and then on each face we can find the landmark points. Landmarks are equals to predictor. We want to find the landmarks, of course, on the EMG gray, and we need to specify the area of the landmarks are, as the landmarks points are in the face. In face rect, this is the area where the face is located, then that's where we want to find them. And now we need to define the predictor that we haven't defined yet. Predictor is equals to the lib.shape predictor, and we need to have the file of shape predictor. Also, you can download this one from the link tutorial in the description. Okay, here we can now detect the landmarks. Now let's first see if the landmarks detection is correct. So we loop through all the 68 landmarks points for n in range 0 to 68. We take from the landmarks the x landmarks dot part n dot x, and the same for the y. We take x and y of each single point, and we're looping through them. This will be from 0 to 68, so we will have all the 68 points, the coordinates x and y, and let's put them inside an array. Landmarks points is equals to an empty array, and then each time we find each single point, we'll put inside landmarks points array. Landmarks points dot append, and we will put inside x and y each time. Once we have all the points, we can let's first draw all the points one by one. cv2.circle on the image, and then the center is of course x and y. The radius, let's make it 3 pixels. The color, let's make it red, so BGR format 0 blue, 0 green, and 255 of red, and thickness of -1, which means to fill the circle. Let's run the script. And here we have our detection correctly detected the 68 landmarks points. Now is the next important step that we haven't yet seen in previous videos, and it's called the convex hull. The convex hull will be the external area of all these points, so will be the biggest polygon but only the external area. To make an example, if we take the landmark points, convex hull is a function that in geometry will return us only the external area with one particular thing, that the degrees inside the polygon cannot be bigger than 180 degrees. Let's look carefully what it means. So let's first take the external area this way, and later this way. Now I take only the external points in this image, and we can see that taking only the external point inside the image, we still have a big rectangle, one angle which is bigger than 180 degrees, which is this one is bigger, and also this one is bigger than 180 degrees. With the convex hull, we cannot have such angles inside. That's why the image will look this way. It will look something like this. It goes straight, not to keep the angles of 180 inside, and it will be this way. We don't need to do much with Opencv, as we have the function already built in Opencv. Just using the landmark points, we can do this way. cv2.convex hull, we use the point landmarks points, and that's all. Of course, we will get the result, which is the convex hull, which will be all the points that define this area around. So let's run really quickly to see if everything is correct. It's a bit slow, and we get an error in this case. Type error, points is not an NumPy array, neither a scalar. When we work with Opencv, we cannot work with straight simple arrays made in Python, but we always need to convert them into NumPy array. So these landmarks points, we cannot use it. Then landmarks points, let's create a new array. Point, let's just call it points, equals to mp.array, and we take landmarks points, and we define the type of the array, integer 32. The reason why we use NumPy all the time, because NumPy it's made to work faster with arrays, as Python is a slow language, and Opencv requires a lot of speed to detect especially things in real time. So that's why we need to use NumPy array always. After we convert the points into NumPy array, we then can find the hull. So points, we'll use hull is equal to cv2.convex hull of the points, which is a NumPy array. And now let's run this again. Let's see if we don't get any error. We can move on and we can show the hull on the screen. Okay, we don't get any error. It means that it's working correctly. Now that we have the hull, let's first print the hull. Print hull to see what's inside this hull. And we can see it array of array with many points, but I don't like to call it hull. Let's call it with the real name convex hull. And now we can show the convex hull on the screen. So let's draw the polygon using these points. cv2.polylines on the image, and the point is convex hull. And then, is it closed? Yes, the polygon must be closed. We want it to be closed. The color, we want the polylines in blue color, so to distinguish them from the red points of the landmark points. And thickness, let's say 3. And let's run the script and let's see the detection. And as I explained before, this is the convex hull. Some of you might wonder why just not use straight the external point of the face. So why not just use point from point 0, this one, to I cannot see the number right now, 16 here, and then the one of the eyebrows. Well, the reason is simple, because if we rotate the face on the perspective, you will not see anymore one part of the face, and then the points of the nose will be, for example, the external points, not anymore the points of the jaw. This is one simple reason why we always need to use the convex hull. We have the convex hull, Now we need to use this to create a mask. So somehow now we need to extract the face that is inside here. To extract the face, we need to create a mask where and using that mask we can say extract only the part that we are not covering with the mask. So we will cover all the part outside the convex hull, and the part inside will be able to extract it. Let's go on and let's do this right now. Let's create a mask. Mask is equals to, first let's create an empty mask, which will be a black image with the same size of the original image. So mask is equals to np.zeros like emg. A quick explanation: zeros like, it means we are creating an image like emg with only the difference that every pixel has the value of 0, and value of 0 in Opencv means black color. But also, now I did a mistake. No, we're not creating EMG but a mask like EMG gray, as the mask must be one channel. Otherwise we will have a mask in 3 colors format, and we don't want that. And my voice is disappearing for some reason. Mask, and let's also display the mask. cv2.im show mask. It's a black image with the same size of the original one. So I will show you so you can see what it is. I'm not joking, this is for real. That's the mask. Now in this mask we need to select this specific area with the convex hull, and we want to make it in white. And then now we have the function to fill this area of the convex hull. It is cv2.fill convex poly. We want to do this on the mask. The points are the convex hull points that we found before, and the color must be white. So the number 255, we run the script. We need to put this mask over the original image. The black part is the part that we are not taking, and the white part is the only one that we are allowing. That in this way we'll get only the face. And we can do this with bitwise operators. So it's simple. We will call this Bradley face, or even let's call it face image 1, not to get confused later on when we will change the picture. Face image 1, and is equals to cv2.bitwise and we take the image to eyes, and then we place the mask. Mask is equals to mask. And if you want to know more about these bitwise operators and basic operations on the image, I'll suggest you to check my complete full series on my website, and you will understand in more details how this works. Anyway, now let's check the face image 1. cv2.im show face image 1 and then face image 1, and we can run it. Here we have extracted the face. And of course, let's remove these blue lines and these points, as I was using them just for matter of explanation. We don't need them. So polylines, I'm just commenting them, and circle, I'm just commenting this line. And let's run again the script. And this is the result. We will do in the next video the same process for the second image, and then we will try swapping the images. And please give me any feedback. Let me know if the explanation was clear, if I was going too fast, if I was going too slow. And see you in the next video.